Hello students, RT welcome to you for this academic year 2020-21. Okay. I will be handling part of the mathematics syllabus. Already my colleague Professor Udaya has started his classes. I will be engaging the mathematics classes. 50% of the syllabus I will be engaging. Okay. See, after having studied for your board exam, prior to that, the 10th standard high school classes, right, or starting from LKG till PUC, whatever sound background you have as far as mathematics is considered, right, it's going to help us in understanding the topics of degree syllabus. Fine. Here in degree, in BSc, many of you have opted PCM, some have opted PMC. PCM is a basic science course where mathematics plays a very important role. See, whether you study physics or chemistry, without a sound knowledge of mathematics, you are not able to do well there in other subjects. So your focus should be in mathematics. If you are good in mathematics, you will be good in every other subject. That's very, very clear. Right? If you are good in mathematics, you are going to do well in every other subject, including language. Fine. So in the first year BSc mathematics, as my colleague already told you, I suppose, there are 4 units which we are sharing 2 units each. Okay? So my topics are mainly based on your functions, domain of the function, the value of the function exists, value of the derivative exists, right? Differentiability, continuity, right? Differentiability, continuity, and related matter. The first derivative test, second derivative test, you are studying in PUC. Similar tests are there here. Concavity, point of inflection, right? These are the things to be studied during your first semester course. For anything, right? The foundation set theory. We need to have a sound knowledge of set theory, functions, right? And limit, continuity and differentiability. These are very, very important. Let us have a small bridge course for this BSc syllabus. Before we start the syllabus, we will just connect a few topics here which you have studied at lower classes. Okay, like see, the first semester mathematics bridge course for you. Topics which we would like to cover in the bridge course. What I would like to cover: sets, relations, functions, right? Functions, limits or limit, continuity, and you are reaching up to differentiability, a little bit of differentiability. Fine, differentiability. So sets, relation, functions, limit, continuity, differentiability. This is actually the base for the 2 units which I am going to cover. It is a profound knowledge of these topics required to move with the topics in base. Okay. So as far as studying mathematics is concerned, I once again repeat, you have to be very, very regular in your work. You cannot keep today's work for tomorrow or tomorrow's work for day after tomorrow and so on. No. You have to be very, very regular, very punctual. You have to be attending each and every class. But however, these days you are going to attend the class online. Online, that is a recorded system we are using here. I am going to send notes for the syllabus of first year BSc. For bridge course, I am not going to give any other notes material. Whatever I am going to discuss here, you just note down that. Right? In your notes, to begin with your notes, You just make a note of this. First SEM Mathematics Bridge course. The topics to be covered in the bridge course by me. These you just mention in the notes. And whichever point you find right necessary, more necessary, right? That means you have studied, you have forgotten, you have not studied, not come across. If any such things are there, please scribble down in your notebook as far as bridge course topics are considered. After the bridge course, maybe 2 or 3 classes I will move with the bridge course. And after the bridge course, we are beginning the syllabus, actual syllabus. Syllabusally, the concavity, right? The continuity differentiability, curve sketching, right? Point of inflection. All these things we are going to study here in one of the unit. In the other unit, we will discuss a little later because I think the syllabus is being posted there in the Google Classroom. You go through the syllabus of Unit 1, Unit 2, Unit 3, Unit 4. However, prior to this, we will have to discuss a few topics which I am going to begin with today. You are listening from far distance. Sometimes there may be an internet problems, network problem may be there, but you have to manage it. You have to manage to download the video, okay, and also the materials which is going to be sent to you, and study that. And in case you have any doubts, you are free to clarify the doubts by putting your comments there. So before I engage in the second session, I am going to attend your doubts and then continue. Okay, your doubts will be attended first, then continue in the second session, third session, all remaining sessions, right, will be preceded by doubt clarification of yours in case you pose any doubts. Okay, fine. So we will take a few topics for bridge course. Sets. You take a non-empty set A. By saying that set A is non-empty, what do you mean? You mean that the set contains at least one element. A be a non-empty set. Set must contain at least one element. Consider its power set P of A. P of A is the power set of A. Power set of A. What do you mean by power set? It is set of all subsets of A. Set of all subsets of A. Set of all subsets of A. I'll take a small example here. Okay. You take the set A with 3 members A, B, C. List all the possible subsets here. Singleton set. A singleton set containing only one element. Singleton B, singleton C. One element set type, one element subsets. Go with 2 element subsets. AB, BC, C. 2 element subsets. Then we take 3 element subset. That is, every set is a subset of itself. We have studied every set is a subset of itself. That is A itself. A is a 3 element subset. And you know that null set is a subset of every set. Other one is null set. Total how many subsets are there? 1, 2, 3, 4, 5, 6, 7, 8 subsets are there. When the set contains 3 elements, when A has 3 elements, you have 2 power 3, that is 8 subsets. 8 subsets are there. Right? If a set A has n elements, how many subsets, how many elements is P of A? P of A will contain 2 power n elements. The number of subsets of a given set A, which has n elements, is 2 to the power n. 2 to the power n subsets. Right? We have 2 to the power n subsets. Fine? It's a power set of it. So from the power set, you move on to the Cartesian product of 2 sets. It is A cross B. Cartesian product of 2 sets A and B denoted as A cross B. It is a set of ordered pairs AB, where A belongs to A and B belongs to B. This you have studied, right? You studied this Cartesian product of 2 sets. Here, Suppose the set A has m elements, B has n elements. How many elements? Number of elements in the cross product is 1. Number of elements in the cross product, it is m into n. M into n. This you have studied, right? We are just recollecting the informations which you have studied earlier in your lower classes, right? So what's important here is just to refresh your knowledge and then proceed. So if A has m elements, B has n elements, number of elements in the cross product is m into n. Okay? So from the set, subset, Cartesian product of two sets, we move on to relation. What is a relation? A relation R. A relation R from set A to set B. A relation R from set A to set B. It is a subset of A cross B. It is a subset of A cross B. What does A cross B contains? All ordered pairs. AB, where A belongs to A and B belongs to B. Fine. So if it is a subset of A cross B, a relation contains a set of ordered pairs, collection of ordered pairs, in which A related to B is true, in which A or B is true, A related to B is true. R is a relation from A to B which contains ordered pairs. That's what we say. It is a subset of A cross B. A cross B contains set of ordered pairs. So a relation will contain a set of ordered pairs in which A related to B is true. A related to B is true. Fine. So you'll ask question. If A is set with m elements, B is set with n elements, how many relations are possible from A to B? How many relations are possible from A to B? Relation is a subset of A cross B. A cross B contains m into n elements. Since relation is a subset, for a set with n elements, how many subsets? 2 power n. 2 power n. For a set with m into n elements, how many subsets? 2 to the power mn subsets. A relation is a subset of A cross B. A cross B contains m into n elements. Here m, here n, it is m into n elements. So how many relations are possible from A to B? 2 power mn relations. 2 power mn relations are possible from A to B. Right? 2 power mn. Suppose you want to define a relation on a set A. That is a relation on a set A. The mapping is from A to A. If A has n elements, B has n elements, right? Then the relation from A to A is a subset of A cross A. Right? A has n elements. Again, this also has the same number of elements. A cross A has n into n square elements. So how many relations on a set A? How many relations from A to A? It is 2 power mn, where m equal to n. It is going to be 2 power n square relations. 2 power n square relations on a set A. Right? That is a relation on a set, relation from one set to the other set. Right? A to B. Fine. So sets or relations. A relation may be reflexive, symmetric, or transitive. That is what the types of relations. Types of relations. Now the types of relations: reflexive, symmetric, and transitive. Right? Transitive. You can also define an equivalence relation. Fine. When you say that a relation is reflexive, a relation on a non-empty set, A relation R on a non-empty set is said to be reflexive if every element is related to itself, X or X, for every X belongs to A. Reflexive. Symmetric. Whenever X related to Y implies Y related to X for all X comma Y. For all X comma Y belongs to A. Symmetric. X or Y implies Y or X. Transitive. Whenever X related to Y and Y is related to Z, together implies X related to Z. For all X, Y, Z belongs to A. You know this notation? It is for all. This notation is for all. You know there exists. There exists. This notation is for there exists. There exists. The for all, there exists. Such that it is for such that. Right? What is this notation means? What is this notation means? Right? Sudarma is here listening to my class. He is a topper, state topper, one of the state topper of our own PU college. Isn't it? What is this notation? Means belongs to. Okay, belongs to notation. Belongs to. There exists such that. Okay, belongs to. For all X comma Y comma Z belongs to A. So reflects whether every element is related to itself. Symmetry. Whenever X is related to Y, then Y is also related to X. Transitive. When X is related to Y and Y related to Z, then X is related to Z. First one related to third one, that is transitive. Equivalence relation. A relation R on a set A is said to be an equivalence relation if R is reflexive, symmetric and transitive. If all the three properties are satisfied, reflexive, symmetric and transitive. Reflexive, symmetric and transitive, then R is an equivalence relation. A relation R on a non-empty set A is said to be an equivalence relation if it is reflexive, symmetric and transitive. Fine. I'll pick one or two quick examples. Okay, as far as these relations are concerned. The one we have already cited down. For a non-empty set P of A. P of A is power set of A. Power set is a set of all subsets of A. Power set of A. Set of all subsets of A. You consider the relation R to be a तरह relation. What is this? What is this relation? Right? It is a subset of. Is a subset of. This relation is a subset of. Is a relation. Fine. Is a subset of. What about this relation on the power set? Is it reflexive? Clearly it is reflexive. It is reflexive why? It is reflexive because every set is a subset of itself. Every set is a subset of itself. Right? For every A, right, belongs to P of A. Every set is a subset of itself. Reflexive. Is it symmetric? The reflexive one. It is not symmetric. Why? Whenever A is a subset of B, this need not imply. It implies anything. Implies cut money. Need not imply. Does not imply. Okay. B is a subset of A. Right? If A is a subset of B, all the elements of A are contained in B. Does it mean that all the elements of B must be in A? No need. Therefore, if A is a subset of B, B need not be a subset of A. Need not be a subset of A. Symmetry fails. Transitive. Transitive is obviously true whenever A is a subset of B and B is a subset of C, certainly A is a subset of C. A is a subset of C. Right? If A is contained in B and B is contained in C, then A is contained in C. It is transitive. So E is a subset of relation on the power set of a given set. It's reflexive and transitive but not symmetric. Reflexive and transitive but not symmetric. Okay? Before we conclude today's session, I will add one more example. Okay? Take set of natural numbers. Take the relation divides relation. Divides relation. Whether divides relation on the set of natural number. The least natural number is 1. 1 is the least natural number. 1, 2, 3, etc. up to infinity. There is no last natural number. Least is 1 and there is no last natural number, and natural number set is an infinite set. Set is an infinite set. But infinity is not a last natural number. Infinity is not a number at all. Infinity is not a natural number as well. Right? 1 is the least natural number. There is no last natural number at all. Fine. So divides relation. Every natural number x divides x, no doubt. Because 0 is not present here. It is true. It is true for every x belongs to n. Reflexivity holds. Symmetry fails. Why symmetry fails? Look at this. 2 divides 4. Does it imply 4 divides 2? No. 2 divides 4 but 4 does not divide 2. Symmetry fails. Transitive. Yes, it is transitive. Why transitive? Because whenever x divides y and y divides z, for any three natural numbers x, y, z, this certainly implies x divides z. X divides z. For all x, y, z belongs to n when they are natural numbers. Natural numbers. The least natural number is 1. Right? Okay. So reflexivity holds. Every natural number divides itself. Transitivity holds, but symmetry fails. The relation divides. The relation divides on the set of natural number. On the set of natural numbers is reflexive and transitive, but not symmetric. It's not an equivalence relation. So I will just conclude today's work by adding an example for equivalence relation. To take a set of all triangles in a plane. Set of all triangles in a plane. Let the relation R be is congruent with. This is an equivalence relation because it is reflexive, symmetric and transitive. Why it is reflexive? Every triangle is congruent with itself, reflexive. It is symmetric because whenever a triangle x is congruent to y, then y is congruent to x. Symmetric. Transitive also. If a triangle x is congruent with the triangle y and triangle y is congruent with z, then triangle x is congruent with the triangle z. It is transitive. It is reflexive, symmetric and transitive. Right? So this is an equivalence relation. The relation is congruent with on the set of triangles in a plane is an equivalence relation. Equivalence relation. Equivalence means that is reflexive, symmetric and transitive. Fine? Okay. So I'll just give you one question, you get me the answer. You can post your answer in your Google Classroom. Okay. I'll write the question down. The question to be answered by you and it is to be posted in the Google Classroom. Google Classroom where you are just now getting familiarized. Okay. Let A be the set 1, 2. And give the smallest possible example so that all of you must answer the question, and I must see your answer in the Google Classroom at the earliest. As soon as you go through this video, you have to answer the question and put it in the comment box there, Google Classroom. Right? All these things may be new for you. For us also it's quite new. Right? Hopefully I am facing you. Here actually when I take the classes, I am addressing only empty benches here. Empty benches are here. Right? I am assuming the presence of X, presence of Y, presence of Sudanma, presence of Shruti, etc. I am assuming the presence of all the 45-50 students and delivering the lecture here. Okay. So I want you to answer one question today. For the set A equal 1, 2, how many reflexive relations? I have not given any clue for this so far. During my discussion, I have not given any clue. I have yet to deliver that. But in advance, let me ask the question so that tomorrow I will continue with the same topic. Fine? How many reflexive relations? How many reflexive relations can be defined on the set A? How many reflexive relations can be defined on the set A? Is the question. How many are the count you have to give? How many? Right? How many benches are there? You have to give the count. Not only count, you have to list them. List multiple relation R1, R2, R3. Right? How many reflexive? I don't know how many are there. There may be 1 or 2 or more, I don't know. You have to check and tell me. How many reflexive relations are there on the set A, which has got 2 elements, 1, 2. Right? What is your answer for this? And I will meet tomorrow. Right? Where we begin our discussion with this answer to this question. And also, I'll check how many students are completing or giving the right answer for this question. I repeat the question. For the set A with 2 members, 1, 2, how many reflexive relations are possible on A? And which are they? You have to give the list and count. List and count. Okay? Thank you. Have a nice day.